Assalamu Alaikum, my name is Amash Masriaz. You are watching my YouTube channel. In this video, we will solve a mass balance question related to crystallizer operation without chemical reaction. In this video, we will also see that how you can convert the descriptive form of question into the pictorial form so that you can solve the question easily. So the question will appear on your screen. You can pause the screen to read the question. I will also write the question in the description of this video so you can consult wherever you require. So the question says that we are having a crystallizer. So we are having a crystallizer and it is charged with a feed of 100 kgs, having barium nitrate solution, aqueous solution of barium nitrate. So in water, so barium nitrate and water. So I can write as its mass fraction as barium nitrate as 0.25 and remaining water will be 0.75. So defining the weight fractions or mass fraction, you can write as W. So now in crystallization, what happened? We cool the solution. So after cooling, crystallization will happen. So after cooling the cooling to 283 Kelvin, in the problem says 10% of the total water evaporates. So this stream I name as C1. I don't know its flow rate, and it's consists of only water, because in question it says that no barium nitrate is leaving from the water that is evaporating. So now I will come to the mother liquor. I will name as C2, and mother liquor will also have barium nitrate and water in it. So the stream for the crystals I will name as C3, and in the question you have told to find the yield of the crystals, and in the question it is said that no water is accompanied with the barium nitrate crystal. So this stream will have only barium nitrate in it and no water will be present in it. So now you can see that we have write the descriptive form of a problem into this pictorial view, so it will be easy for us to now solve. If we read the question thoroughly, so you can see that we can find a lot of unknowns that I have written over here. The first unknown that I can find is the question says that on cooling 10% of original water will evaporate. So what it will be the amount of water? The amount of water will be 0.75 multiplied by 100. So 75 kgs of water is present. So its 10% will evaporate. So what will be its 10%? Its 10% will be 7.5 kgs. So here you can write as 7.5 kg of water will evaporate. So you have found one number of unknown. So now in the question it also says that the solubility at 283 Kelvin of this mother liquor solution is 7 kg barium nitrate per 100 kg of water solution. So from this value you can also find the mass fraction of barium nitrate and water in this mother liquor. How? Let's see. So 7 kg of barium nitrate is present in 107 kg of solution, because the solution is having 100 kg of water. So I can rewrite as 7 kg of barium nitrate plus 100 kg of water. So it will become 7 divided by 107. 7 divided by 107 will become 0.0654. So here the mass fraction of barium nitrate in the mother liquor will be 0.654 and the remaining amount will be for water 0.9346. So now from reading the questions I have found 1, 2 and 3 number of unknowns that were present. So now we have find it out all the unknowns. So now let's proceed to solve the problem. In the problem you have to find the yield of the crystals that have been produced. This thing you have to find in the problem, or you can say the mass of the crystals that has been produced. So I will raise something and make my space here in the whiteboard. So as we also so now what is the first step for solving a mass balance problem? The first step is to find the degree of freedom. So what is the degree of freedom? It is number of unknowns minus the number of independent equations. So what are the number of unknowns? The number of unknowns you don't know C, that is the number of unknown number 1, and you another don't know the C3, and it is another number of unknowns. So 1 plus 1, the number of unknowns will become 2. For moving to the number of independent equations, the number of independent equations are 2. We are having 2 components in our mass fraction, barium nitrate and water. There are also here is also barium nitrate in water, barium nitrate, and here only water. So as we are having only two species in all our feed streams, so the number of independent equations will be 2. So 2 minus 2 0. So degree of freedom is 0. So this question will have a unique solution. After moving after finding degree of freedom, we will go to the general mass balance equation for solving this problem. So what is general mass balance equation? Accumulation is equal to input minus output plus generation minus consumption. So now as it is a steady state process, so accumulation will be equal to 0, no generation and no consumption, all will be equal to 0. So we will remain with input is equal to output. So let's start with the application of our mass balance. So two balances you will use here. One will be overall mass balance and one will be component mass balance. Overall mass balance and component mass balance. So now we will start by the application of component mass balance. Till this location I cannot apply overall mass balance because I am not having C2 and C3. So let's start with the application of component mass balance. We will apply the first component mass balance for barium nitrate. So the barium nitrate component mass balance will be weight fraction of barium nitrate multiply its feed stream, and this is the only input. So output, we are having 3 outputs. In C1 we don't have any barium nitrate, so I will write as 0, and in C2 you are having weight fraction of barium nitrate multiply C2 plus in C3 you are having all barium nitrate, so weight fraction of barium nitrate multiply C3. So now I will input the values. So here will be 0.25 multiplied by 100 is equal to 0, 0.0654 multiply C2, and here it is C3. So now the equation will become as 25 is equal to 0.0654 C2 plus C3. So now I will apply another mass balance for water. So I can apply it here. For water component mass balance, so I will write it directly as 0.75 multiplied by 100. Here I am having 7.5 kgs. If I multiply 1 with 7.5, so it will become 7.5. Here I can write as 0.9346 multiply C2 plus in this C3 I don't have water, so it will be equal to 0. So 75 is equal to 7.5 plus 0.9346. So 75 minus 7.5 divided by 0.9346 is equal to C2. So now if you solve this, you will get as C2 as 72.20. So now here we have found out that our C2 is 72.20. You can write the value of C2 here and you can find C3 as well, or you can also do this by overall mass balance. So now how you can find it by overall mass balance? So overall mass balance input is 100 kgs of feed, 7.5 plus 72.2 plus C3. So now you can subtract 100, 7.5, you can subtract 7.5 from 100, also 72.2. So you will be left with C3. So the amount of C3 is 20.28 kg is C3. So the C3 is 20.28 kg. So in this way we have found out the yield of crystals that have been produced in this question. I hope you like the video. Inshallah, meet you in another video. I will make another video for a problem that will be on crystallization, that will be having a difficulty level a little higher than this. I hope you like the video. Assalamu alaikum.